Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about TreeSet in Java. So by the end of this video, you will understand what TreeSet is, how it stores data, its internal working, features, methods, and advantages, limitations, and we will see when to use TreeSet. So let's get started. So what is TreeSet? TreeSet is a class that implements the set interface. So before learning any collection, we should be knowing the hierarchy of the collection. So iterable is the parent interface, then collection, which provides common methods. Okay, it will provide common methods such as add all, remove all, size, is empty, search. So those kind of common methods will be provided by collection interface. Okay, and collection interface again has the three child interface: list, set, and queue. Okay, so these are the child interface, and set has the three implementation class. What are those? HashSet, LinkedHashSet, and TreeSet. So we are learning TreeSet. So before learning any collections topic, hierarchy should be clear in the mind. Okay, which collection we are learning. Okay, so these are what implementation classes. HashSet is implementation class, LinkedHashSet is implementation class, TreeSet is implementation class. But implementation class means it is implementing which interface? It is implementing set interface. Okay, so we should know the hierarchy before learning any collections. Okay, so TreeSet is a class that implements the set interface. Okay, like every set implementation, it stores only unique elements. Okay, and TreeSet automatically stores element in sorted order. So 2 pointers you should keep in mind. One is ordering and another one is sorting. Okay, ordering and sorting. Ordering means insertion order, the order in which elements are getting inserted into an collection. That is ordering. If it is maintaining order, we will say it maintains insertion order. Sorting means it can be either ascending or descending. So TreeSet provides sorting and no ordering. Okay, it does not provide any order. No ordering, but it provides sorting. Okay, so it is written TreeSet implements the set interface. That's why TreeSet is the implementation class of the set interface. It stores only unique elements. No duplicates are allowed. It maintains sorted order. No ordering but sorting. It does not maintain order of insertion, but it provides sorting. Okay. And TreeSet is a part of Java collection framework. Okay. So let's see the hierarchy of the TreeSet. Okay. So TreeSet implements the navigable set interface. Okay. So I told like set interface has three implementation class. One is HashSet and another one is LinkedHashSet and the last is TreeSet. But TreeSet is not directly does not directly implement the set interface. Instead, it implements navigable set, and navigable set is the child interface of sorted set, and sorted set is the child interface of set interface. So that is the hierarchy. That is the hierarchy. So if you go from the top, iterable is the parent interface. Okay, and collection is the child interface of the iterable. In collection, we have the common methods. Okay, it is the root interface for collection. Why we are saying root interface of our collections? Because collections interface has child interface, list, set, and queue. Okay, so this is a root interface for most collections. So we are learning for now set. Now set interface again has child interface sorted set, and then sorted set has again child interface, that is navigable set. And TreeSet is the class. Focus on the word. TreeSet is the class which implements navigable set. That's why we say TreeSet as implementation class. Okay. So the hierarchy should be clear in mind. Okay. Only two things are adding here. We already know that set interface has 3 implementation class. Okay. But for TreeSet is implements navigable set, and navigable set is the child interface of sorted set. Sorted set, by name it is clear that it will sort elements ordering. It will sort the elements. Okay. So TreeSet is the implementation class of the set. Okay. Sorted tree based set implementation. Okay. So TreeSet implements the navigable set interface which extends sorted set. This allows TreeSet to provide sorting along with powerful navigation methods. What navigation methods? Like higher, lower, ceiling, floor. So these are like navigation method. Okay. So this can be used as part of TreeSet implementation class. Okay. I hope the hierarchy is clear. So let's look at the internal working of the TreeSet. Okay. So TreeSet. Okay, TreeSet. Whenever I say TreeSet, so first point should come with sorting. It will provide sorting. Okay. And next point should come is like it uses red black tree. Okay. Red black tree. It is a self-balancing binary search tree. Okay, what is binary search tree? What is self-balancing? What is red black tree? These things we will see as part of data structure and algorithm DSA. But here we are learning TreeSet. So as part of TreeSet, we must know that it uses internally red black tree as a data structure, which is a self-balancing binary search tree. Okay. That means whenever an element is added or removed, the tree automatically balances itself. Okay, you can think, I will give you a brief. So let's say the structure of tree is like this. Okay. Structure of tree is like this. Okay. So whenever we add or remove any element, okay, here we will be having element 10, 20, 30, 40, 50, 60, 70. Okay. So the binary search tree, it will get automatically balanced. Let's say if I remove this one, or if I remove this one 20, then this tree will be automatically balanced. Okay, that's why we are saying self-balancing binary search tree. If you are thinking how it is automatically balanced, then we need to study DSA. So that topic will be covered as part of DSA. But for now, as part of TreeSet, we will be knowing it uses red black tree, and which is self-balancing binary search tree. If we perform any insert or delete operation, the tree gets balanced automatically. Okay, and it ensures efficient searching and sorting. Okay, so TreeSet means first point we should remember is sorting. So elements remain sorted automatically even if we are adding or removing the elements. So that is the internal working of the TreeSet. In most of the interview questions, the collections, internal working and internal data structure used is being asked. So this is the very popular topic for collections. Okay. So let's look at the features of TreeSet. What are the features of TreeSet? So Since TreeSet implements the set interface, so unique elements will be allowed. And TreeSet provides sorting, so it will sort in ascending order by default. Okay. So whenever we create, let's say TreeSet and some variable, reference variable name, new TreeSet. Okay. Like that we will create. And let's say if you want to, so if you create an object like this, okay, so XYZ will be in ascending order by default. Why? Because we have not provided anything. We are not telling, okay, give this tree set in descending order. So by default it will give in ascending order. And let's say if we are telling here, okay, we want to get in descending order. Okay, so here we have the concept of comparator. Okay, I will tell you later. But if you want it to be descending, we need to give some extra thing here. Otherwise, by default, it will be in ascending order. Okay, so it will give the sorting in ascending order by default. And we know that for TreeSet, it is no ordering, only sorting. So no ordering means it will not maintain the order of insertion. It does not remember the order of insertion. That's why no insertion order. It does not support index-based operations. It is faster in search than normal binary tree. Okay. Normal binary tree. If it is comparing to normal binary tree. It is a balanced binary tree. Okay. Self-balanced binary tree. Binary search tree. We call it as BST. Binary search tree. Okay. Balanced search tree. So it is faster in search. Yeah. So TreeSet provides multiple constructors. Okay. So the default constructor here I was telling you, right? This was like constructor. Okay, it will call constructor. So if we are not providing anything, that means default constructor will be ordering in ascending order. And if you are passing another constructor, okay, that accepts a comparator for custom sorting. Okay. So these are the features of TreeSet. So let's look at some of the common methods used in TreeSet. Okay. So common methods. Okay, before common methods, let's complete this null handling. So we know, right, in hierarchy, we have iterable, collection, and then collection has 3: list, set, and queue. And set has again HashSet, LinkedHashSet, and TreeSet. Okay, but here we should know the difference. Okay, so we say, okay, null values are allowed as part of set interface, but there are 3 implementation classes: HashSet, LinkedHashSet, and TreeSet. So only one null is allowed in HashSet and one null is allowed in LinkedHashSet, but no null values are allowed in TreeSet. These are the difference. Okay, so only one null values are allowed in HashSet and LinkedHashSet, whereas for TreeSet no null values are allowed. See, null values are not allowed. Only one null. Why it is asking only one null? Because the remaining implementation classes provides this facility of storing one null values, whereas in TreeSet we cannot store even one null value. No null values are allowed. Okay, null values are not allowed. Okay, this is null handling. Okay, so besides standard set operations, TreeSet provides navigation methods. Why? Because TreeSet implements navigable set and navigable set is the child interface of sorted set, and sorted set is the child interface of set interface. So we know this hierarchy, right? So these methods, these are the common methods, and these methods are provided by the navigable set, some of the methods. Okay, so what are these? Add is used for adding an element, remove is used for removing an element, contains to check whether the element exists in the tree set or not. So these are the methods, first, last. These are the methods provided by navigable set. Okay, navigable. So these are navigable navigation methods. Okay, first is used to return first element, last is used to return last element, higher is used to get next greater element, lower is used to next smaller element. Polling means removing first element, removing last element. So if you are knowing the hierarchy of any collection, you can get the methods easily. Since this TreeSet implements the navigable set, and navigable set is the child interface of sorted set, and sorted set is the child interface of set interface. So this is the hierarchy. If you are knowing the hierarchy, you can get, okay, TreeSet is implementing navigable set. So we'll be having navigation methods. Okay. So the hierarchy is very important in the collections framework. Okay. So for TreeSet, these are the time complexity. So if for adding, time complexity is O of log n. For removing, it is O of log n. And for search, it is O of log n. So we should remember the time complexity for TreeSet. It is O of log n for adding, removing, or searching. Okay, why? Since TreeSet uses a balanced red-black tree, insertion, deletion, and searching all take O of log n time. Okay. So we know this diagram, right? So these are the set interface, iterable, then collection, which provide common methods, add all, add, contains, remove all. So these are the common methods provided by collection interface, and set is the sub interface or child interface of collection. So we know these properties. It allows only null values, only one null values, does not allow duplicates, does not support index based operation. Okay, and these are the implementation classes. HashSet. So LinkedHashSet extends the HashSet implementation classes, and HashSet is the implementation class which implements set interface. And we have seen TreeSet, and in between there will be navigable set. So TreeSet will implement, TreeSet is what? Class. Okay, so TreeSet is a class which implements navigable set, and navigable set is the child interface of sorted set, and sorted set is the child interface of set interface. Okay, so this is the hierarchy. So let's quickly compare the all implementation class of the set interface. Okay, so we know HashSet, LinkedHashSet, and TreeSet. So first point is duplicate. So since we know these all implementation classes are implementing set interface, and set interface has the property no duplicates are allowed, only unique elements are allowed. So duplicates will be no for all three implementation classes. Second point is order. So we know ordering and sorting, right? So HashSet will not provide no ordering, no sorting. So it will be unordered. Order means here LinkedHashSet we know it will provide ordering but no sorting. So order will be insertion order. So it will maintain the order of insertion, the order in which elements are getting inserted. And TreeSet will not maintain any order. It does not follow ordering, but it provides sorting. So order will be not there. Okay, sorted order. order will be not there means insertion order, but it will give the sorted order. So by default, which kind of sorting it gives? Ascending order. Okay, and if we want any custom ordering such as descending, then we need to pass the comparator in the constructor. Okay, so these are the difference for the ordering. Now null values. So only one, we have seen only one null values are allowed in HashSet, one null values are allowed in the LinkedHashSet, but for TreeSet, no null values, zero null values. Okay. And internal data structure we have seen for HashSet, it is hash table, which uses hashing algorithm internally, and the internal data structure for LinkedHashSet we have seen, it is the combination of hash table and linked list. So hash table will give hashing algorithm, so that's why faster in performance. Plus linked list means it maintains the insertion order. Okay, plus some memory overhead. Okay. Internal data structure for the tree set is red black tree. What is red black tree? Red black tree is a self-balanced binary search tree. Okay. So these are the differences between internal data structure for all three implementation classes. Okay. And now the performance. Hash table uses hashing algorithm, that's why it is fastest in performance. HashSet is the fastest in performance. And linked HashSet, since it uses linked list, okay, hash table will give fast, no doubt, but linked list will give memory overhead. Okay, because linked list, there will be chain of nodes. Each node will refer to another node, and these all nodes will be sitting in the heap memory. It will be memory overhead. Okay, that's why somewhat less fast, you can say like fast in performance. It will be less fast compared to HashSet. Okay, and TreeSet will be slower. Why? Because it is sorting, it is giving sorting. Okay, self-balanced tree. So these are the differences between these three implementation classes. Okay, so HashSet is the best for faster in performance, and linked HashSet is preserving insertion order, while TreeSet automatically keeps the data sorting. So each one has their own unique property. Okay, so if you want faster in performance, we'll select HashSet. If you want to maintain insertion order, you will select linked HashSet. If you want sorting, then you will go for TreeSet. So based on our requirement, based on our need, we will select the appropriate implementation class. Okay, so for that we should be knowing the features of each implementation class. Oh, that's why I have given a quick comparison so that making decisions will be easier for you. Okay. So we are learning as part of this video TreeSet. Okay. So I have just given you a quick glance. Now we will see the advantages of the TreeSet. We are learning TreeSet. So what are the advantages of TreeSet? It will give you automatic sorting. By default, it will be ascending. If you want custom sorting like descending, we need to pass comparator in the constructor. Okay. And no duplicates are allowed since it implements the set interface. Efficient searching. Okay, BST, binary search tree, it is efficient searching. And it supports navigation method. We have seen poll first, poll last. Why it is supporting navigation method? Since TreeSet implements navigable set interface, which is a child interface of sorted set, and sorted set is a child interface of set. Okay, so that's why it supports navigation methods. Okay, and TreeSet, first point we should remember is it provides sorting. So it is useful for sorted data. Okay. So TreeSet is useful when you always need data in sorted order. Okay, without writing sorting logic separately. You don't need to write the logic of sorting separately. It will automatically give you sorting. Okay. So let's look at some of the limitations of the tree sets. Okay, because tree set maintains sorting, right? It performs slower than HashSet. Okay. We have seen HashSet is the fastest in performance. Okay. It is slower than that. Why? Because it is providing sorting. It needs to sort the elements. If you are providing 30, 10, 20, then it needs to sort 10, 20, 30 like that. Okay. So that's why it is somewhat slower. Okay. And it also does not support indexing. It does not support index based operation. That's why no indexing. And does not allow null values. And also no ordering. It does not maintain insertion order. Okay. For TreeSet it is no ordering, but it will provide sorting. This we have learned for TreeSet. Okay. So these are the limitations for the TreeSet. Now, when will you use TreeSet? When we will choose TreeSet? So when you need to store sorted data, you want to store your data always in the sorted form, then you will go for TreeSet. And duplicate elements should be not allowed. That means whatever data present in the TreeSet will be unique and sorted. If your requirement is unique and sorted, you will go for TreeSet. And additionally, you will get navigation methods. Poll first, poll last, first, last. Okay, these are the methods. And frequently searching sorted elements. If you want to perform searching operation frequently for the sorted elements, then you should definitely go for TreeSet collection. Okay, so we should know the feature, first of all, hierarchy and the features, and based on that, first we should analyze what is our requirement, and based on our requirement we should take the decision. Okay, I need sorted data, I need elements to be unique. In that case I will choose TreeSet. Okay, so that's how we should select the collections which to use. So let's quickly summarize what we have learned so far. Okay, so TreeSet implements set interface indirectly. Okay, directly it will, we know the hierarchy, right? Navigable set followed by sorted set and then set. So indirectly it implements set interface. It stores unique elements. Duplicates are not allowed. And what is the data structure it follow? Red black tree. Okay, that is self-balanced binary search tree. What it is we will see in the topic of data structure and algorithm. But for now we should know that TreeSet internally uses red black tree. And what is red black tree? It is a self-balanced binary tree. That means the elements will get balanced automatically. If you are removing this element, then all remaining elements will get adjusted and again it will form the same hierarchy. Okay, so it is self-balanced and it maintains sorted order. By default it gives ascending order, and if you want to get in the descending order, then we need to pass in the constructor. It does not allow any null values. Okay, zero null values, zero null, no null values are allowed. And the time complexity for performing adding, deletion and search operation is O of log n. So that's all for this video. I hope this tutorial helped you to understand the concept of TreeSet in Java. Thanks for watching and I will see you in the next video.